This one-point lesson is a quick tour of the VMES software. It'll show you how to interpret the factory floor, how to find the factory metrics, how to do engineering work, and how to use the cost accounting tools in the VMES. This lesson is divided into 5 parts. First, we'll look at the server status and then the line status. Then we'll look at the factory metrics. Then I'll show you how to do engineering work in the VMES, and I'll show you how to use the cost accounting analysis tools. We'll do this lesson by completing 5 example tutorial problems. Okay, problem 0. Let's explore the VMES and the server status. And then we'll resync the VMES client to the VCF by pressing the Control R button. Let's jump over to the VMES software. You can see the server status here on the lower right-hand part of the status bar. The status alternates between showing you whether you have new updates ready and when the next update is scheduled. So the next regular update is scheduled for 10:09 p.m. UTC. UTC stands for Coordinated Universal Time. Next, we'll sync the VMES software to the VCF server. That can be done by either clicking on View and choosing Refresh, or pressing the Control R key. I'm going to press the Control R key to resync the VMES software to the server. When I do, you'll see the status update here on the lower left-hand part of the status bar. Like that. Now that the download is complete, your VMES software is now synced to the server. Let's go to problem 1. Now we'll explore the VMES through the Metrics tab. We'll do a couple of parts here of this problem, and I'll leave the rest of the parts for you to do on your own. The first question asks, what is the current status of the text etch process step? You can see the status of the process step by hovering over the icon for that particular process. So here you have the text etch process, and it shows you the status is productive. That means it's currently producing solar cells. The second question says, what is the plasma depot chamber's plasma power for the arc process step when it is active? All right, let's have a look at that. We can see the status of the tool by viewing the tool console. The tool console shows you the status of the process in the tool for any given process. Right now we can look here and find the plasma power for the tool is 125 watts. Question 3 asks, how many lots are waiting at the WIP input buffer at the dep/diff process step? You can see the WIP input buffer is the vertical column here to the left of the dep/diff process tool. You can see the status by hovering the mouse over that vertical bar. It shows that there are 1 lots currently in the WIP buffer. Question 5 asks, what was the mechanical yield loss rate on WD 1.6? WD stands for work day 1.6, so that's week 1 and day 6, or Saturday on week 1. We can find the mechanical yield loss by clicking on the MY loss tab, which will show us the rate of mechanical yield loss as a function of week and day. Weekday for 1.6 is here, 1.1, 2, 3, 4, 5, 6. And then we can read off the chart here. So the mechanical yield loss rate is approximately 70,000 dppm, or defective parts per million. We can also copy the chart data by right-clicking and selecting Copy Chart Data. And then we can paste that into Excel, like this. So now we have a data table showing all of the mechanical yield losses as a function of week.day. So here's the answer for 1.6, 61,250 defective parts per million. Question 7 asks, what is the cost of goods manufactured on weekday 1.6 in dollars per watt? We can find the answer here on the cost of goods manufactured per watt chart. For week 1.6, we can look here and find out it's about $1.95 per watt. We can also copy the data and paste it into Excel and then find the answer in numerical terms, $1.94 per watt. Okay, on to problem 2. Let's explore some of the engineering capabilities of the VMES. First, we'll do a data query. Part 1 asks, query the lot median efficiency of all production lots at finished goods inventory. So let's go to the Engineering tab and we'll select Data Query and Export. Then we can set up the query parameters for our query. So we'll select first the FGI process step, We want to include all data of all weeks, so we've set this correctly. We want production lots. We want both the current FGI database and the archived FGI database. We want the lot median, and we want efficiency. So once we've set up the query panel, you can click the query button, and that will show us the results of this query. The median efficiency for all lots currently at FGI. Part 2 asks, estimate the mean and standard deviation of all the data collected in Part 1. Okay, here's a trick in the VMES. We can select all of this data by clicking here on the upper left-hand box and then right-clicking to copy selection. Now we can paste this data into Excel. To get the average, we can use the Excel average function. And to get the standard deviation, we can use the Excel standard deviation function. And there we have it, the average and the standard deviation. Okay, on to problem 3. This problem explores the engineering action planner tool of the VMES. The problem states, submit an engineering change control to change the following recipe settings on the DepDip process tool. So the engineering action planner is located here on the engineering menu. Click the action planner bar, and then let's do a change order. So click the change order tab. Now to create a new change order, we right click here in this upper left hand box and click add new activity. So that adds a new change order. We can type in a comment. We can select the recipe that we want to change. That will be DepDiff. And then we can edit the recipe. So now we find the recipe that we are required to change, zone 1 temperature. We want to change the zone 1 temperature from 450 to 451. So we click OK button, and then we click OK. Now that creates an engineering change order that will be executed by the VCF server sometime in the near future. Okay, on to problem 4. Explore the cost analysis capabilities in the VMES. We'll do problem 2. This problem says, create a bar chart of cost in units of dollars per watt for the top 20 cost contributors. For example, wafers, oxygen, etc. Okay, so we can find all the cost analysis tools here on the cost menu. And to get the information we need, we'll click the Manufacturing Cost Summary tab. This gives us a summary of all the costs in the factory. We want to do the analysis for week day 1.6. So we can set week day 1.6 here, week 1, day 6. And we want the units in dollars per watt. So that's here in the Performance Cost tab. So now we have all the data we need, and we can get that data by, again, left-clicking here in the upper left box, and then pressing, for example, Control-C. Now we have the data, and we can paste it into Excel. Now I'm going to create a bar chart. So first, I will sort the data from highest to lowest by column L, like this. So here we have wafers, 91 cents per watt. Now I can create a bar chart by selecting the correct data and inserting a column chart like this. And there we have our Pareto chart of cost for the top 20 costs. Okay, that's it for this OPL. Let me summarize with a few important takeaways. You can find the server status indicators at the bottom of the VMES software on the status control panel. You can find all the line status indicators on the factory floor. All the factory metrics are located on the tab control, and the analysis and planning tools are located on the menu bar. There are a lot of other capabilities of the VMES, and those are described in the course textbook. If you have any questions or comments about this one-point lesson, please contact me at this email address.